This is exercise 14.100. It's a question from the homework that many of you struggled with, so I thought I would record the solution. What volume in milliliters of stomach acid can be neutralized by the antacid tablet? And this antacid tablet requires 28.2 milliliters of 0.210 molar HCl to reach the equivalence point. So what I'm going to do is going to calculate how much base is in the acid tablet. I'm going to get the moles of that. And then I'm going to calculate second how much stomach acid can be neutralized with that amount of base. A couple things to remember: that at an equivalence point, the moles of acid equals the moles of base. So there are going to be times when I go from talking about acid to base and I'm going to be using the same number, and it's because it's at the equivalence point. Okay, so for one, I'm going to calculate the amount of base in the antacid tablet, and for that I use this information. It takes 28.2 milliliters or 0.0282 liters of 0.21 molar HCl to reach the equivalence point for the tablet. And so if I multiply 0.210 moles over liters, remember molarity is moles over liters, then the number I get is 0.00588 moles of H plus was used to neutralize that antacid tablet. Now remember, that means that that's equal to the number of moles of OH minus in the antacid tablet. Okay, so now that's how much is in the antacid tablet. What volume of stomach acid can be neutralized with that? Well, if I know that my stomach acid has a pH of 1, I can calculate the concentration of H plus in the stomach acid, because that is equal to 10 to the minus pH. 10 to the minus pH is 10 to the minus 1, or 0.1 moles per liter H plus in the stomach acid. So then the question becomes, what volume of this solution has the same number of moles of H plus as 0.00588 moles of hydroxide? Because I'm looking at the equivalence between the moles of the antacid tablet now and the moles of acid in the stomach. So if I have 0.00588 moles of H plus in the stomach, and I multiply by 1 liter over 0.1 moles of H plus, I'm getting that from this concentration here, then my number becomes 0.000588 liters of stomach acid. However, this wants it in milliliters, wants the answer in milliliters. So I'm going to multiply that by, this should be, I have the wrong number here. I went the wrong direction with the decimal. This should be 0.00588 divided by 0.1. That's the same thing as multiplying by 10. It should be 0.0588 liters of stomach acid. Now, if I multiply my 0.0588 liters times 1 liter is 10 to the third milliliters, then I get 58.8 milliliters of stomach acid. And that is my answer.